Good morning everyone, welcome back to Question a Day. Today is July the 7th and we'll be answering today's question on inequalities. And before we begin, today's World Chocolate Day, so I've got myself a little chocolatey treat that I will be having after I've completed this question. It's a little bit of a reward. So today's question is we want to find the set of values of x for which both 2x minus 2 is greater than y minus x and x squared minus 6x is less than or equal to 40. So as you can see here, I've already started drawing my coordinate plane with our x's and our y's. We'll be wanting to use one of these to represent these two inequalities on so we can find this region and write it as an inequality. Sorry, that camera's shaking a little bit, but hopefully I'll fix that there. Okay, there we go. Probably not the most reliable setup there. Wonderful. Okay, so the way we're going to begin this, we've got 2x minus 2 is greater than y minus x. Well, we want to rewrite this. It's probably going to be a straight line because we've got a y term and we've got an x term. So we can rewrite this equation if we bring all the x's over to one side. Well, this is going to be 3x minus 2 is greater than y. And I can indicate on my diagram, I'm going to treat this as a straight line. This is minus 2 down here. And it's going to have a gradient of 3. I'm going to take my ruler and draw on a dashed line to indicate that it has a gradient of 3. So this dashed line here. And the reason I'm doing it dashed and not all joined together is because of that greater than. So because this is strictly greater than y, we don't want anywhere on this boundary where it's equal to y. So now we're going to look for where this value is bigger than y, and we can intuit here that we're looking for this region, because this is where I put in a value of x. Say I put a really big value of x in, like 200. Well, on this side, that 200 is going to be, so 200 is going to be clearly greater than y. Whereas on the other side, y is going to be greater than our 3x take 2. So that's our first curve. Our second curve is this x squared minus 6x is less than or equal to 40. So we're going to indicate on here the y-intercept of this. So it shouldn't be up here, actually. I've jumped one step ahead of myself. What I'm looking for is x squared minus 4x is take 40 is greater than 0. So I'm looking for x squared take 6x take 40 is less than or equal to 0. And that's what I'm looking at in this diagram. So we want to find the intersection of these two regions. Now, with this quadratic, what we can do is we can factorize it. So we can look for factors, and I think this will factorize fairly nicely into x minus 10 and x plus 4 is less than or equal to 0, which we have our values of, so our roots, we've got one here up here, which is going to be 10. Actually, what I'll do, I'll just make this in a slightly different color, so it's easier to see for you. So we have, here we go, a 10 here, and on the other side, we've got a minus 4. Now, this curve is going to span that region there. Again, it doesn't have to be incredibly precise. I've just drawn this sketch so I can use it. And I want to find the values of x, so I don't really care about the values of y, but I do care about these values of x. And I'm looking my roots. I want to look at the direction in which this curve is less than 0. So here we're below the x-axis, which means my value of this curve is less than 0. And then outside of that, the value of this curve is greater than 0. So the region of x values that we're considering here are these ones. Okay, just quickly one little bit of information that we could use here as well. We probably want this coordinate here of where our straight line intersects the x-axis. So we can set y is equal to 0, and this should be a value of 2 divided by 3. So we can have that noted down as well. Now what this indicates is we can now come up with the intersection of these two regions. So our first region follows this rule where x minus 2 is greater than y. Our second region follows our other rule that minus 4 is going to be less than or equal to x, which is less than or equal to 10. So now we can look at the intersection, and actually the intersection of this region, I'll just get another colour to make this a bit more visually interesting. The region that I want is actually just this line here. So we're getting rid of this entire area because we've not got any y's in this second equation. We're just looking at the values of x. And what we can do as well, we would just want to constrain this. We're intersecting minus 4 to 10 with, well, this 2 over 3 and 10. So this section here. And the actual inequality that we want is that 2 over 3 is less than, so it's strictly less than because of this less than sign here, because 2 over 3 would not satisfy this rule. 2 over 3 and so that's less than or equal to x, which is then going to be less than or equal to 10. And that is our solution to this problem. Now we can look at y values and see that, well, for our y values, that's going to span all the way down and upwards. But in our question, we're told we don't need to worry about the y values. You're only told about the x values. But if you wanted, you could look at this entire region and work out exactly the range of possible y values there. And they would change depending on your x value as well. That's all for today. Another long one, but the next one tomorrow will be a little bit shorter than that. So thank you very much everyone for watching, and I am going to enjoy my chocolate bar.